So let's see. I am machining the cap for the quick shifter, and this is the cap. Obviously the piece of aluminum is too big for the little part that I'm gonna get out of it. So first thing we're gonna do is shave 2 millimeters from the top or the bottom here. I'm gonna do it in 2 passes, 1 millimeter each, with 3 millimeter radial depth of cut with the settings or the tool. It's a 1/4 inch 3 flute end mill, 100,000 millimeters per minute, or whatever those settings are. These are my passes. So I'm doing 3 millimeter step over with a 1 millimeter step down, and I'm doing a final finish pass of 0.1 millimeters. So that's the operation you guys just saw. And that's the final pass. The one that is almost done doing now is this one and this one. You can see I'm doing multiple passes at 6 millimeter step downs. Actually 6 passes at 0.5 millimeters step over. That is the second one. That's the finishing pass. Actually, it's the one on the bottom. It's not a finishing pass, or is it? I don't remember. No, it's not. It's just doing the outside. And then now what you're seeing on the video is gonna do the bore. It's this. So it would be that one. That's what it's doing now. And I'm doing a 0.5 millimeter pitch. And I'm reducing it by 0.06 millimeters. It's a little oversized. Then it's gonna do the thread on the outside. So this is Well, the size doesn't matter because it's not standard size, but it's a 1.5 millimeter pitch. And last, you'll do the chamfers on the outside and the inside. So one here, and the internal one. So those are the other two. So that would be the stock. Those are the two passes plus a finishing pass. You can see I'm going past the size of the cap or the length of it because when I machine it, I want to make sure that it's clean, just in case there's an issue here with the proper zero on the z-axis. It's going past it by 1 millimeter. I was doing the threading. Is this? On the model, it doesn't show the thread because I didn't put a thread on it. I don't know how to set the thread without reducing the size. Every time I select the thread, it changes the diameter of the part, so I'm just putting the thread on it um, without having it on the design itself. And this is a very long video. I believe it's like 25 minutes, maybe 30 minutes. That is because I'm playing the entire video on both operations, just to give you an idea of how long it takes to make a part. Obviously on the second operation I did additional steps that are not really required. I just wanted to have them there just in case I need them. But it takes a while. It depends on how fast you want to go, the finish you want to get with these little machines, and obviously the tool life. If you want your tools to last, then you have to not go too fast or too slow, and you have to do you have to get some chips out. You don't want to be just going really light or too heavy. So I did a second pass there because it wasn't dragging all the way down. Now it's just going to change the tool. And if you notice, I have not measured the z-axis at all. I did it once at the beginning, but I'm not doing it anymore because I have the limit switch as a touch-off way to measure the tools or the offset of the z-axis from the part to that switch. So every time I change the tool, I can just go measure the difference and assign the offset, and I'm good to go. So right now with a chamfer tool, it's gonna go and touch it off, and it'll get the proper zero. You can't see it because it's behind the collet, but on my previous video you can see the how the whole thing works. It makes it a lot easier to just switch tools and not have to worry about constantly measuring the Z height, or if you have burrs, you don't have to worry about those screwing up with the actual zero. And you can keep everything within the same operation because you don't have to remeasure. You can go off of the original one. So it's done with the bottom side, and now what's it doing now? Oh, I'm just setting up the end mill for the next operation. Yeah, I was supposed to do that without a tool installed because it would be very easy for me to cut myself with the end mill since it's so close to my hand. And let me remove this out of the way so you can see the part. Move back a little bit. There's the part. There you go. There it is. Did it restart it? Alright, let's go back to where it was. Let me go forward. There it is. Pause it. Alright. So now it's gonna switch the collet for something smaller to hold it from the threaded side. Remove the stop. And now it's gonna do the back side. So let's go back to this. And flip it around. And now it's gonna do this one here. So there's a lot of material to remove here. So it's gonna do multiple passes, 1 millimeter at a time. It's doing a few things. So it's facing, contour, and then the profile, pot drilling, and then drilling, chamfer. And I didn't do this one. This is just chamfer on the holes, on those, not really needed. So let's just run the entire thing here, see how it's gonna look. Come on. There we go. So before I go, so you can see that I'm setting the zero at the base of the part right here. So if I go to this one, you can see where it is right there, right at the edge of this line, which is where the collet is. And let's just run it. So there's gonna be a lot of shaving. I just have those pieces of aluminum that are a little too long, too lazy to cut them off. So I'm just gonna go through the entire process. A lot of facing off. And then it's gonna profile the part. So that's pretty much all it's gonna do. So let me move forward one to where it's down facing, so we'll have to watch that whole thing. Right there. So you can see the board just came to view. That's because of the additional millimeter uh, cut. Now it's gonna do a finishing phase. Let's see if I can get a picture. So up to that point, I could just do a chamfer and that would be done with the second operation, but I decided to do the additional holes. That's just mainly for the glue or the epoxy having something to grab onto when I attach the sensor to it. Alright, let me let me get a picture going here. So this is the part. Where we go? There it goes. So this is the sensor that goes on top of the part. You can see it has some holes in there for the epoxy to grab onto, and also obviously those holes there to grab onto as well, so it doesn't move or slide out. The fit's pretty tight, so it wouldn't move. It also has this tabs, and it goes with the shrink tubing, so it grabs onto it pretty good, but just want to have something else to grab onto. You can see the sensor's pretty simple. It's just the sensor, a capacitor, and then you have your 3 lines for connecting your wires. Go back to this. So now it's doing the spot drilling, which would be that one. Oh, it went all the way through. That one, spot drilling. Let me move forward a little bit more. Oh, it believe it finished because that video wasn't long enough. So let me bring up the other one. So that was the second part. And if I can spin it up forward, since I don't have the controls here. restarting this thing. See. So a lot of tool changes. Doing a part, there's always a lot of tool changes, so that touch off tool or sensor or switch, I guess, comes in handy because you don't have to reposition the zero. It does it on its own. So you just have it, you just remove, add a new tool, doesn't matter the length, and then just send it again. That's a 2.5 millimeter drill, by the way. The flat drill was a 3 millimeter. And it's going 2.5 millimeters down. So it's not going all the way through, it's just putting a shallow hole for the epoxy. Now the last tool was the chamfer. And by the way, as you can see on the video, well, you can't see that much, but this machining is relaxing, at least to me, really relaxing. I'm not in a rush to get it done. I just want to cut some stuff, make some stuff, make it work. So there's no rush. I'm trying to do it fast. Obviously, this is like a 30-minute 2-operation cap on this little machine. Could be done faster, but you know, what's the point? I like that part though, just installing the tool and touching it off without having to remeasure. I have to make a sensor though, so it can do it faster. I have to go that slow because otherwise it goes past the sensor limit and it might break it. So I need to do something for the machine, and then I'll be good to go. Was the outside chamfer and the internal. Was that oh, maybe the other one was internal. Maybe this one. And then just a tiny bit of the edge, just to remove the sharpness. And I believe that's it. The part should be done. That was my second one. I did the first one just to adjust the recipe to the way I wanted it, and then the second one was, once I was done, just went with it. It still needs another adjustment on the grenade itself because I have to do 2 passes, and I like to do it in a single pass because that is a slow tool to use. Let me remove this. Alright, so there's the part. Not bad for a 3018 machine. As you can see the little bird at the bottom where the thread starts. The chamfer wasn't that deep, but that's okay. Nothing touches that part. And the thread looks pretty clean. You can see some marks, lines. That's because it's going too fast. The spindle is only going at 8,000 RPMs, and it was going at 300 millimeters per minute. To get it nice and smooth, it needs to 200, at least on my machine. But it's okay, still good. You can see the facing marks. Those are 3 millimeter face marks. So that was the step over. The inside is clean as well. It's just I guess it's like aluminum powder, and it gets stuck to it because of the alcohol and water mixture. And that's the top side. That's the last operation or the second operation. Oh, it looks so pretty. So let's see. That's it. That is the part. So there's the one here is the one I'm showing in the video. This is the one I did first with the sensor. So that's the entire process of doing a cap. Lengthy process, but like I said, relaxing. So till next time, enjoy.